Alright, in this video I'm going to take a look at graphing inequalities. So just kind of real quick what an inequality is. An inequality, rather than having an equal sign, you're going to have a symbol that's either less than, greater than or equal to, less than or equal to, something like that. So I kind of wrote out kind of the basic steps for graphing one of these. So step one is to kind of graph the equation, but you need to know what kind of line to use. Anytime you have a less than, an equal to, or greater than or equal to, if it's got the equal to sign, you're going to have a solid line. And if you don't have the equal to sign, you're going to use a dashed line. Now, after we have a graph, step two is to test a point on our graph to determine if it is a solution, and then shade that side. So if it is a solution, you shade the side that has the solutions. That's kind of our third and final step. So moving on to our example here, let's suppose I have the following example. I have y is less than negative x squared minus 2x minus 1. Well, once again, I want to start by graphing this equation. Now, before I even graph it, I might just make a side note to myself. Notice I don't have an equal to sign, so my line has to be a dashed line. So that's just something to keep in mind before I write it down. Now, if I look at this and I want to graph this, I notice that this is in standard form. So anytime I graph a quadratic in standard form, I need to find my vertex. And the way I find my vertex is I take the opposite of b over 2a, and then I'm going to plug that back into the function to find my y value. So opposite of b over 2a will give me the x value, plug that back in, that will give me the y value. So in this case, my vertex is going to be the opposite of b. Well, in this case I have negative 2 as my b, so I'm going to have positive 2, and that's going to be over 2 times my a. My a is negative 1, so that's going to be over a negative 2. And then, as you can see, that's going to be simplified to just be negative 1. And then I can plug negative 1 back into my function here, and it'll tell me the y value associated with it. So anytime I plug a value into a function, I normally write it above the function's variable. So for instance, I'm plugging negative 1 in for x, so I'm going to write negative 1 above it. Well, if I take negative 1 and square it, that's just going to be 1, but notice there's a negative out front, so it's really going to switch to a negative 1. And then if I take negative 2 times a negative 1, well, that's just going to be a positive 2. And then I also have this negative 1 off to the side that I'm subtracting. And if I take negative 1 plus 2 minus 1, well, that's just going to be 0. So in this case, I have negative 1 comma 0. And once again, that's going to be where the vertex is at on the graph. Now, usually, once I have the vertex, I want to go ahead and plot it. So I'm going over 1 and up and down 0, so I'm at negative 1. And then once I have the vertex graphed, I then want to use my a in my equation. So my a right now is this negative 1 in front of the x squared value, and I always put it over 1. This kind of acts like a slope. It'll tell me where my next 2 points are. So for right now, my a is equal to negative 1, and I always want to put that over 1. Okay, and then once again, that's just the coefficient on the x squared term. Now, the way this kind of works is the negative 1 will tell me how much I go up when I go over 1. So it's kind of like your rise over run on a linear graph, but it doesn't work quite like that, but it's very similar to a linear graph. So in this case, when I go over 1 to the right, I'm going to go down 1. And then when I go over 1 to the left, I'm going to go down 1 as well. Okay. Now you can see that my graph is going to be a quadratic curving through those 2 points, headed in the downwards direction. Now the last step here really is to check a point and see if it is a solution. So normally the best point to check is the 0, 0 point if it's there. And if I look at my 0, 0 point, this origin point, I want to know, is that origin point a solution to this inequality? And the way I can see if it's a solution or not is plug 0, 0 into this inequality and see if the statement's true. So I'm going to do that off to the right hand side here. Well, if I plug 0 in for y, I just get 0. And then if I plug 0 in for the x squared, well, negative 1 times 0 will just be 0. If I plug 0 in for this x, I'll get negative 2 times 0, which will just be another 0. And then I'll have minus 1 off to the end. And I'll get the statement 0 is less than negative 1. And if I think about that for a second, 0 is not less than 1, so that is false. And since that's false, I know that 0, 0 is not a solution, and I only want to shade in the solutions. So in this case, I will want to just shade in the internal region. Because this is on the outside and it's not a solution, I don't want to shade any of that in. I only want to shade in the things that are the solutions. Okay, so only the solutions get shaded in. I don't want to shade in any of the non-solutions. Now, I already forgot, but this is why I wrote it down at the very beginning of the problem, and make sure you don't forget this. Here we had a less than sign, not an equals to sign, and it's dashed. I need a dashed line. What that means is, see how I've drawn this bold line on my parabola? That would be incorrect. And the reason why this is incorrect is because it's telling me that all the solutions on the line are included in this problem. But that's not true. So what I need to do is make this a dashed line. So I should have dashes on my line. It should not be a solid line. So each of these points should be a dashed line. What that means then, by drawing a dashed line, is that those are not solutions. The line itself is not a solution. The solutions are only on the inside of the line. Okay? So make sure that you don't mess that up. Make sure that if you have a less than sign or a greater than sign, you use the dash line. So just to kind of summarize here real quick, when graphing inequalities, your first step is to figure out what type of line to use, whether it should be solid line or dashed line, and that's based off of whether it's less than or equal to, greater than to equal to. Your next step is to test a point and determine if it is a solution. And then the last step is to shade the area. So you want to shade the area that has the solutions.